Hello friends, welcome to Learn Positive with Pradeep Kumar. If you are watching my channel, like, share, comment, subscribe, click the bell icon. Today's subject is Strength of Material, Unit 2, Simple Stress and Strain, Part 3. If you want to see all my previous videos, click the I button on the top of the video, and if you want to see another subjects I have taken, visit my channel and see all the videos. Don't forget to subscribe. The first topic we are going to see is load. What is load? The external force acting on a body or a structure is known as load. For example, imagine a boxer is punching a man on his face. So it is said to be the load given by the external load given by the boxer to another man. So this is the load or pressure. And the next one is stress. So the boxer is kick a man with a load, external load. So it creates a stress inside the body of the man who was bitten. So the bitten man gets stress on his face. So due to the stress, the load was applied in the area that is called his face. The load given by the boxer, external load is given by the boxer, so it is called stress. So we can calculate the stress by the formula, the ratio between load to the area of cross section of that section, that is load by area. By using this formula, we can calculate the pressure given by the boxer and the area of the punched area. So the ratio between them are said to be the stress, and due to stress there will be a strain. So just imagine the boxer is punch him on his face. Due to that, the stress is happened. So due to the sudden load on that particular area, the stress is happened heavily. So due to the stress, the beaten man's face gets strained with a strain. So the muscle will pop up at the area where he punched up. So it changes the dimension of his face. So this is the strain. Due to the stress, the strain was happened. So we can calculate the stress strain by the change in dimensional divided by original dimension of the cross section area. So by using this formula, we can calculate the strain itself, the ratio between the change in dimension to the original dimension at that section. So imagine a balloon. We are going to give a pressure inside the balloon. That is, the pressure is said to be here as a load. So due to the pressure, the balloon is expanded. By giving a more pressure, by giving a minimum pressure, we cannot blow the balloon to the bigger size. So when we are increasing the pressure more than the balloon takes, it becomes expanding. So this is said to be the stress. When you are increasing the stress by the pressure, the balloon becomes expanded. Due to the stress, the balloon change its dimension from the original dimension to the change in dimension by smaller size to the bigger size. When you are going to blow the balloon more than this, means it becomes blown up. So it gets busted by the more strain. Now we are going to see the types of forces or stresses, classification of force system. So the first one is tensile stress, the second one is compressive stress, the third one is shear stress, and the next one bending stress, finally torsional stress. These are the stresses we are going to see in detail. The first one, tensile stress. What is tensile? When we are pulling a object, so it is said to be the tensile stress. So think a bar was fitted, a MS rod was fitted on a gripper, top and bottom, and we are going to pull the rod. So due to that, axial pull is given to the cross section area. So due to that, the bar becomes elongated. So it changes length, increasing in length by decreasing its cross section. So due to this, the tensile stress is happened. Wherever the stress is happened, there will be a strain also. So here we get tensile strain. So due to the ratio between the increasing in length to this original length, so we can calculate the length of the rod before we are going to give tensile stress, and we are going to calculate the rod after giving this tensile stress. It becomes increasing in its length and decreasing in its cross section. This was shown in this image. You can see it clearly. Due to the gripper, the rod was giving tensile load and it becomes bigger and smaller in its cross section area. And now we are going to see the next one, that is compressive stress. You can see the image. What is the compressive stress? In first image there was a ball between two gripper. So in the second image I am going to compress the ball by the grippers. So due to this, the height of the ball becomes decreasing and the cross section of the ball becomes increasing. Look at this diagram. Due to the compressive stress, the round rod becomes smaller in height and it was getting bigger in this cross sectional area. So this is said to be the compressive stress. The axial push, the ratio of axial push to the cross sectional area, it is said to be the compression stress. So wherever the stress, there will be strain. So the compressive strain is decreasing the ratio between the decreasing in length to the original length. It is said to be the compressive strength. We can calculate by using this formula. And the next one is shear stress. So wherever the axial pull or push, due to that the cross sectional area is changed and it in the ultimate stage it become sheared off into two pieces. Now see this image for an example. I am going to fix a rod in between two grippers and giving a tensile force in it. So due to the tensile force, the neck is formed and it changes its length. And now I am going to increase the load and giving more tensile stress. The rod cannot be withstand, so it will break. It will shear into two parts. So this is said to be the shear stress. You can see now the rod, these two both rods are the same one. Before we are going to give the tensile stress, the rod is the length of the rod is smaller, and after giving the tensile stress, the length of the rod becomes higher and the neck was formed at the center. After the elastic limit, the bar going to be broken. So this is the test piece, example test piece. So we can see clearly how the length of the rod is increases and the neck was formed and it was broken into two parts. So this is said to be the shear force. When we are going to compress, the same will happen in the rod. So it is going to be reducing its size, and after maximum stress it becomes broken. So it is said to be the shear stress. Wherever the stress, there will be the strain. So this is the change in dimension, ratio of the change in dimension to its original dimension. So it is said to be the shear stress. And the next one is bending stress. So due to the bending stress, when a bending load is that is the external force is acting, on the beam or a body. Due to that, the bending moment is happened, and if are increasing the force, it will be become the shearing moment. So the bending moment of the section tends to bend or deflect the beam and increases stress, and increases its internal stress to be developed to resist the bending. It is said to be the bending stress. Just for an example, we take a plastic chair, and the plastic chair can withstand the weight of 80 kgs, but we are going to place a load more than the 80 kgs, like 110, 140, 160, like that. The chair is going to be bended due to this bending moment. And if we are going to increase the load by like this, it will becomes sheared. So the bending stress is said to be the external load is increasing Due to that, the internal stress is developed to resist the bending. It will become gives the bending moment of the material. And the final one is torsional stress. The torsion is another word, it is a twist. So when we are going to twist a material, the torsion stresses happen inside the material when a machine member is subjected with two equal and opposite couples acting in a parallel plane. Then the member is said to be in torsion. The stress included by its torsion is called torsional stress. So now imagine I am going to fix a square bar in a gripper on both sides, and now I am going to twist the one end of the gripper in clockwise direction. So due to this left to right clockwise direction, the rod become twisted. You can see it clearly, it is look like a drilling bit, but before that it was a square rod. So due to the twisting moment, we get the torsional stress inside the metal rod. Friends, if you like this video, please give a thumbs up, share with your friends, don't forget to subscribe. Thank you.